Dear students, happy Teachers' Day. I am very thankful to all my parents and all my great teachers, honorable teachers who guide me. Thank you, Anand. Today, we shall study about derivative of composite functions. In the previous class, we studied finding the derivatives of simple functions, trigonometric functions and polynomial functions, etc. Today, we continue our studies finding the derivatives of composite functions. Here, we have to study about chain rule. Theorem 4 chain rule. Let x be a real valued function, which is composite, of two functions u and v. Here u and v are the two functions. Here to be a real valued function of composite function of u and v. That is f of x is equal to v of u or v of u. Here we take t is equal to u of x. Here v composite u, v not u. Here we take u of x is taken as t. Then v of t is equal to v of u. Here u is t by dx and dv by dt are exist. Here dt by dx and dv by dt are exist. Then only we find the derivative of f. We have df by dx, which is equal to dv by dt into dt by dx. Here you have to be a composite function of two functions u and v. Here t is u of x. We take t is equal to u of x. Then dt by dx. dt by dx means we finding the derivative of t with respect to x and finding the derivative of v with respect to t. v of t. Here f is equal to v of t. We finding the derivative of v with respect to t and the derivative of t with respect to x are exist. Then we have df by dx is equal to dv by dt into dt by dx. Here the real valued function is having two composite functions u and v. Now we take, if the function is composite functions of w, u and v. Yeah, let it be a real valued function which is composite of u, v and w or w, u, v. Here f is equal to w, u and v. Or three functions. F is a composite of three functions. It is also a real valued function. We taken here v of x is equal to t. Then s is equal to u of t. U of t. Now here dw by ds and ds by dt and dt by dx are exist. Then we find df by dx. df by dx is equal to dw by ds and into ds by dt and dt by dx. dw by ds, ds by dt and dt by dx means we find the derivative of w with respect to s and finding the derivative of s with respect to t and finding the derivative of t with respect to x and multiply these three, we get the derivative of the function. Yeah, it's the chain rule. It's called as chain rule. We find the derivative of the composite functions by using this formula. Example 1. Find the derivative of the function f of x equal to sin x square. Sin x square. It is composite of two functions here, sin x and x square u of x is equal to t. Then v is f of x equal to v of t. Here dt by dx and dv by dt are present. Here u of x equal to t is equal to x square and v of t is equal to sin t is equal to sin t. dt by dx is equal to 2x and dv by dt is equal to sin t cos t. You know the derivative of sin x is cos x. So cos x is minus sin x. And x square is the x to the power n is the derivative of x to the power n is equal to n into x to the power n minus 1. Therefore, dt by dx is equal to 2x and dv by dt is equal to cos t. By using chain rule, df by dx is equal to dv by dt into dx by dt. dx by dt. Here dv by dt is equal to cos t and dt by dx is equal to 2x. We put the value of t here. Therefore, cos x square into 2x, which is equal to 2x into cos x square. 2x into cos x square. Here, finding the dt by dx and dv by dt. Then finding the value of function df by dx is equal to dv by dt into dx by dt. Finding the derivative of v with respect to t and finding the here I will write this one is dx dt by dx. Here I write here dv by dt with respect to t and finding the derivative of t with respect to x. We get the solution cos t into 2x is equal to 2x into cos x square. Alternatively, we can find this value d by dx of sin of x square, which is equal to d by dx of sin of x square. First, we find the derivative of sin x, sin of sin function. It is cos of x square. Then, finding the derivative of x square, it is 2x or d by dx of x square, which is equal to cos of x square into 2x, which is equal to 2x into cos of x square. You follow these steps or this step, you can find the value of the composite function easily. But here we have to find the derivative of the function, all functions u and v. So first you find the derivative of sin x, then find the derivative of x square and both multiply all of this, find the derivative of the composite function. Next, I will take another problem. Three functions. Differentiate sin of cos x square. Sin of cos x square with respect to x. Here, f of x is equal to sin of cos x square. Sin of cos x square. There are three functions. Sin of cos of x square. Here we do w, v and u. Here we take t is equal to u of x. U of x is equal to t, which is equal to x square, and v of t is equal to cos of t, which is equal to v of t is equal to s is equal to v of t is equal to cos t. Then we find the derivative of function w is equal to s of v. Yes. We can write the formula here. F of x equal to w into u into here I taken v and u. Function of w, v and u of x. Three functions. F of x is u, v and w is equal to three functions here. We find the derivative of these three functions by u of x equal to x square and v of t is equal to cos t and w of s is equal to sin of s is equal to sin of s. Therefore, finding the derivative of the function dw by ds and dv by dt and dt by dx all are exist or not, which again dw by ds is equal to, here first we write dt by dx is equal to 2x and vt is equal to cos t. Derivative of cos t is equal to minus sin t and derivative of w is equal to sin of s is equal to cos of s. Here we find the derivative of composite function df by dx is equal to dw by ds into ds by dt into dt by dx. dw by ds and ds by dt. Here I have taken as b, which is ds by dt. Here ds by dt, vt is equal to ds. Therefore, it's equal to 2. dw by dx is equal to cos s into ds by dt is equal to minus sin t and dt by dx is equal to 2x. We write it as cos of s is cos x square, cos x square into minus sin of t is x square, then 2x. We can write this minus 2x into cos x square into sin x square is the derivative of the function. Minus 2x sin x square into cos x square is the derivative of the function. First you take the u of x is this function, then it's v, then all of this one is w. We take t is equal to 2x, u of x is equal to x square and s is equal to cos of t, then w is equal to sin of s. Finding the derivative of these functions with respect to them. With respect to w, with respect to s, ds with respect to t and t with respect to x. These all are exist. Then we find the chain root by using chain root. Finding the product of these three, we get the derivative of the function minus 2x into cos x square into sin x square. We can find the derivative of this function alternatively, like f d by dx of sin of is equal to by sin of cos x square. Here, find the derivative of first sin of cos of x square. Sin of cos of x square is the sin derivative of sin is cos of cos x square. Then find the derivative of d by dx of x square. Cos x square into, here cos x square is equal to minus sin of x square and find the derivative of x square. It's equal to cos x square into minus sin x square into into derivative of x is equal to x square is equal to 2x is equal to minus of cos x square into sin of x square into 2x. I write here 2x here. Minus 2x into cos x square sin x square. Therefore, we can find this method is a very simple method finding the derivatives of all the functions in the f. Here, find the derivative of sin of cos x square first, cos of cos x square, and find the derivative of again cos of x square. Then find the derivative of multiply. Then cos of x square is minus of sin x square. Then find the derivative of x square. Then multiply these three. Find x square derivative is 2x. Then our product of these three functions derivatives is equal to minus 2x into cos x square into sin x square. We solve some other problems. Third one, y is equal to sin of x square plus 5. I finding the derivative of this by using alternate method only. It's the easiest method also. Dy by dx is equal to. Now find the derivative of sin x. Sin of x square plus 5 is cos of x square plus 5 and d by dx of x square plus 5. Here cos of x square plus 5 write again and find the derivative of x square is 2x but derivative of constant is 0. Therefore it's 2x. Therefore 2x into cos of x square plus 5. Next fourth problem. Y is equal to sec tan of root x. It's a composite function of three functions u, v and w. Here dy by dx is equal to sec of tan root x. First we recall the derivative of sec x. Sec x is equal to sec x into tan x. Then tan x the derivative of tan x is equal to secant square x. Then derivative of root x is equal to 1 by 2 root x because x to the power 1 by 2, x to the power 1 by 2 which is equal to 1 by 2 into x to the power 1 by 2 and minus 1 which is equal to 1 by 2 into x to the power minus 1 by 2, therefore 1 by 2 root x. Recall the derivative of root x. Derivative of root x is 1 by 2 root. You know all these, then find the derivative of the sec of tan root x. Here first find the derivative of the sec x. It may be sec, take it as x. Sec x is tan x. Therefore, we write it as dy by dx equal to sec tan of root x into tan of tan into d by dx of dy by dx equal to sec of tan root x into tan root x into derivative of dy by dx of tan of root x, tan of root x, which is equal to sec of tan root x into tan of tan root x. Derivative of tan root x. Tan x is the second square x. Therefore, second square root x. Then d by dx of root x, which is equal to second tan root x. Tan of tan root x into second square root x into 1 by 2 root x. First, you write the 2 root x, 1 by 2 root x, then second tan root x into tan of tan root x into second square root x, which is the derivative of the function y is equal to tan root x. Finding the derivative of the not give up any functions in the composite functions, you find the derivative of all sec x, tan x and root x also. Then find the derivative of u by v and composite function. U by v is composite function, right? Y is equal to sin of ax plus b divided by cos of cx plus d. Sin of ax plus b and cos of cx plus d. Find the derivative of this one. dy by dx is equal to, it's u by v function. U by v. d by dx of u by v, which is equal to v square v into du by dx minus u into dv by dx. Once again, we call the rational function d by dx of u by v. Here v is v into du by dx minus u into dv by dx divided by v square. Here it is minus. Here v is equal to cos of cos square cx plus b whole square. Here cos of cx plus b into derivative of this one d by dx of sin of ax plus b minus here minus u is the sin of ax plus b, then derivative of d by dx of cos of cx plus d. Here denominator is cos square cx plus d. Okay, then find the derivative of sin of x plus d. First, write the d cos of cx plus d. Cos of cx plus d into d by dx of sin of x plus b. Sin of x plus b is cos of x plus b, and derivative of the x plus b Here, the derivative of ax is a and derivative of b is 0. It's a constant function, therefore into a minus sin of ax plus b and derivative of cos of cx plus d is minus of sin of cx plus d into derivative of cx plus d. It's a composite function. Cos of cx plus d. Derivative of cx plus d is cx the derivative is c plus d the derivative. This derivative is 0. Therefore into c. Therefore we get the derivative of the function. Derivative of the function is cos of here cos of cx plus d. Here also cos of cx plus d gets cancelled. Therefore, which is equal to cos of x plus b cos of x plus b cos of ax plus c and cos of cx plus d cancelled. Then we can write it as sec cx plus d. Sec cx plus d. 1 by cos is sec. Cos of cx plus d 1 term is cancelled. Cos of x plus b into a is remaining. Then 1 by cos of cx plus d is sec cos of cx plus d. Minus into minus becomes plus. Then sin of x plus b, there is sin of ax plus b and sin of cx plus d cos of sin x plus d. It's equal to sin of x plus b is equal to this one. Simplify this one. Sin of this tan of cx plus d into sec cx plus d. Sec cx plus d. Here cos of x plus d is common here. Sec of cos of or sec cx plus d is common here. You can take this one also. Find the cos of cx plus d into d by dx or cos of cx plus d into cos of x plus d into a. Then minus of sin of ax plus b into derivative of the u. V is cos of cx plus d is minus of cx plus d. Then you leave this only. Okay. If you have interest to simplify, you can simplify this. Sixth one, y is equal to cos of x cube into sin square x to the power 5. Cos x cube into sin square x to the power 5. Here it is u and v function. U and v function. Here u is a composite function and v also composite function. Here finding the derivative of uv is equal to u into dv by dx plus v into du by dx. Here d by dx of cos of x cube into sin square x to the power 5, which is equal to, its u is cos of x cube here, cos of x cube constant. Then find the derivative of sin square x to the power 5. Sin square x to the power 5 is equal to 2 into sin x to the power 5 into derivative of sin x to the power 5 is cos x to the power 5, and derivative of x to the power 5 is 5 into x to the power 4. Finding the derivative of du by dx is equal to derivative of sin square x to the power 5, which is equal to derivative of sin square x to the power 5 is 2 into sin of x to the power 5 into sin derivative is cos x to the power 5, and derivative of x to the power 5 is 5 into x to the power 4. Then plus v is sin square x to the power 5 into derivative of u cos d by dx of cos x cube. Here derivative of cos x cube is minus sin x cube. Derivative of cos x is minus sin x, therefore minus sin x cube into derivative of x cube is 3x square plus sin x square into minus sin x cube into 3x square. Then 2 into 5, constant term multiply 10 x to the power 4 into cos x to the power 3 into sin x to the power 5 into cos x to the power 5. Cos x to the power 5, cos x to the power 5, and sin x to the power 5 minus plus, here minus, plus into minus sin x to the power square x to the power 5 into here also 3x square sin x square x to the power 5 into sin of x to the power 3. Then minus 3x square into sin x to the power 5 minus into x cube is the answer of the derivative of this function. Here, finding the derivative of the u. First, we put the cos x cube is constant. Then find the derivative of sin square x to the power 5 is 2 into sin x to the power 5 into cos x to the power 5 and derivative of the. Therefore, here cos cube x sin x cube and sin x to the power 5 and cos x to the power 5. Then here only one function, which is composite of cos x and x cube. Therefore, the derivative is here cos of the, here x only x cube is only for x. Therefore, cos of x cube is the derivative of cos is minus sin x cube. Then find the derivative of 3x. But here sin square x to the power 5. Therefore, we write it as a 2 into sin of x to the power 5. Therefore, the answer of the derivative of the function is this. I will take one more question and problem here. 7th one. Y is equal to 2 into cot of x square. Cot of x square. Dy by dx. Dy by dx. Which is equal to, here 2 is constant. Then what? 1 by root x, derivative of root x is d by dx of root x is equal to 1 by 2 root x. Therefore, here also derivative of x is equal to 1 by 2 root cot of x square, and derivative of root cot x square d by dx of x cot x square. The 2 into 2 by 2 cot x square into derivative of cot is minus cosec square x. Here is x square and derivative of x square. 2 is cancelled. Here 1 by root of cot x square into minus of cosec square x square into d by dx of x square is equal to 2x. Therefore, answer is minus of 2x into 1 by root cot x square into cosec square x square. 2x into cosec square x square divided by 1 by divided by cot root cot x square. Therefore, derivative is minus 2 cosec square x square divided by root of cot x square. Then there was one more question and finish. Prove that the function f given by f of x equal to modulus of x minus 1 where x belongs to R is not differentiable at x equal to 1. Is equal to 1. Here once again we write the modulus function f of x equal to x minus 1 if x is greater than or equal to 1 and 1 minus x if x is less than 1. X is belongs to R because here it is minus of plus 1 is x minus 1 is taken as positive and x is greater than or equal to 1. Minus of x minus 1 if x is less than 1. Therefore, is minus of x minus 1 is becomes 1 minus x. Therefore, I will write it as 1 minus x. Then here find the derivative of the function at LHD and RHD. LHD derivative and RH derivative are equal and finite. Then only the function is differentiable. Otherwise, it is not a differentiable function. Here above x is equal to x minus 1 because above x equal to 1 is x minus 1. Therefore above 1 is equal to 1 minus 1 which is equal to 0. Then we find LHD limit or limit of derivative of LH side is the limit of x tends to 1 minus f of x is equal to limit of x tends to minus f of x plus h minus x which is equal to f of 1 plus h x plus h is at limit this side is less than 1. It is s tends to 0 it is equal to 1. Therefore 1 minus x. Therefore we put it as 1 minus 1 plus h. 1 minus 1 plus h minus f of 1 is 0, then divided by h which is equal to 1 minus 1 minus h divided by h. Answer is equal to minus 1. Then RHD which is equal to limit of x tends to 1 plus f of x which is equal to limit of h tends to 0 plus. Here we take as the function is x minus 1, it's greater than 1, it's RHD. RH is x minus 1, therefore 1 plus h minus 1 minus 0 divided by h which is equal to minus 1 plus 1 cancel, is equal to h by h is equal to 1. Here LHD is not equal to RHD. LHD is not equal to RHD. Therefore the function is not differentiable. Not differentiable. At 1 x equal to 1. Here find the derivative of the function at LHS side and RHS. And they are equal, then only the function is differentiable at everywhere. But here it is not differentiable at 1. Therefore, here LHD is not equal to RHS. Therefore, the function is differentiable. You solve other problem out there, follow the same steps in the. Thank you.